Okie dokie. Now, let us look at this question. We are going to try and solve it, right? So they give us this shape that looks like a combination between, what is it? 1, 2, 3, 4. So it looks like a quadrilateral, four sides, right? So they tell us that POQ, P POQ, right, with the radius of 4, right? They give us 4, and the length of this arc is 7, right? Now they tell you the lines PX, right, and QX are tangent, right? So that means that since they're tangent, this will be at 90 degrees, right? Okay. And at P and Q respectively, right? So they want you to find the angle of POQ in radians, right? So we know that an arc length, right, is equals to the radius times the degree that it subtends, that the arc subtends, right? Therefore, we can say from there that we have an arc of 7 is equals to 4 that, and that is going to be our, this is going to be, excuse me, this divided by 4, and I hope that looks like a 7. No, it doesn't. Let's just take that. Right. So that is our angle, right? So that's A. And then B, they say find the length of PX, right? So how do we find the length of PX? I want to draw a line there, and then that will look something like this, right? This is X, this is Q, right? So these are symmetric, right? You can see that they're symmetric about the X-axis. And this is O, right? So then this O to Q, remember that's the radius, so that's 4 centimeters, and we know that QX, we don't know what QX is actually, to be fair. So that's QX. We don't know what QX is, we don't know what PX is. Do we know what PX is? They don't tell us. Right, but then we know that this is symmetric, so it goes in between the two. So then this angle will then be half of this, right? So let's call this theta 2 or theta B, right? And theta B is equals to half of theta. So it's going to be equals to 7 over 8. And that's gotten from 7 over 4 times 1 over 2, okay? Now from there, we're able to do, this is our hypotenuse, this is going to be our opposite, and this is adjacent. And they want us to find the length of PX, right? So if we find PX, we can, if we find QX, we found PX, because remember they're symmetric. So that would be tan, right, of theta B is equals to opposites being QX, and then the adjacent being QO, which will then be QX over 4, right? And then to get, so this is going to be tan of 7 over 8 times 4 by both sides. 4 is equals to QX, right? And then, all right, so if we put that in our calculator, what do we get? We get so we'll get QX is equals to 0.06. Oh shit, excuse me. That's in that's in degrees. So to get it to degrees, we say 180 over pi, over pi, and that will be, always make sure that you have the right measurements, I think. 7.8 or 7.9 centimeters, right? That's QX. Right. Okay, and now if we go back, they say find the area of the shaded region, right? So how do we find the area of the shaded region? Okay, so if we look at the shaded region again, let's see if we can, if we don't have to make it as complicated. Do we have to make it complicated? No, we don't, right? So we know that this is that, right? And this is at 90 degrees. This is 4, and this is 4.79. Okay. And then we have this situation cutting over here, right? If we can get this length, right, then we can calculate the whole area. And then if we get that, we can calculate this sector over here, right? So let's do that. Let's do that. And remember, this is theta b still, right? So the angle, this would then be area of the triangle, half BC sine C, right? So that's the area of the triangle. And just make sure that's quickly. Yeah, half AB sine C, right? So if this is A, and this is B, and this is C, this, right? So this would be A, this would be C, and this would be B. Okay, do we have sine C? Yes, we do have sine C, it's right there. Do we have B? Do we have A? We don't have A for now, but we do have B, right? But we can calculate A using SOHCAHTOA. So we want this. Remember, this is our right-angled triangle. This is our angle. This is opposite. This is so A is the hypotenuse. So we can say that sine, or cos rather, let's use cos of theta b is equals to our adjacent of 4 that was given to us over A, and then A is then equals to cos of that. Remember to keep it in over 4, keep it in degrees. All right, so that's going to be cos 7, 8 times 180 over pi, right? And that divided by 4. Shucks, what am I doing? Yeah. Right. Cos is adjacent over hypotenuse, right? Yeah, that's not the way it's supposed to be. So this is going that side, and that's, so yeah. So it's going to be H is equals to A over cos, right? Silly mistakes. Cool. And this is supposed to be adjacent, right? So let's not get confused with the small letter A and whatnot, right? So the adjacent is 4. The adjacent is 4. And then we have cos of 7 over 8 times 180 over pi. And that will give us something along the lines of, so this is 4, so let me just write this down, 6. 7 over 8 times 180 over pi, and that will give us 6.24 centimeters, right? So then we can now calculate our area and say that our area is then, let me just zoom in a bit, our area is then going to be equals to 0.5 times 6.24. What's b? B again is 4 times sine of 7 over 8 times pi, 180 over pi. And I hope you can see that. Okay, so that will be 0.5 times 6.24 times 4 times sine 7 8 times 180 pi, right? And that will give us our area. And we getting 9.57 centimeters squared, right, for that area, for this area over here. So to get the area of the sector, remember area sector, and this is triangle, right, is going to be half r squared theta. Let me just make sure about that quickly. I think I might have it switched around there. Yeah, it's fine. So that's our radius, half times 16, okay, then 4 square times 7 over 8, okay? So this is going to be 16, so it's 8 times 7 over 8. And that just becomes 7, right? So therefore, we can now say the area of this shaded area, right, is just going to be 9.57 minus 7. And since there are 2 of them, we'll times it by 2. And that will give us minus 7 times 2. What? Okay, 9.57 minus 7 times 2 should give us something about 5. Yeah, 5.14 centimeters squared. And that is